Hey, Dr. Ray here, founder of the Learning Liaisons, and welcome. Welcome to our Wednesday evening math sessions featuring our math specialist and your math specialist, Amy Sink. In the next hour, Amy has put together a sample set of approximately 10 practice questions that run the gamut from kindergarten levels all the way through 12th grade high school math. Now, I know you are attending here, watching this, and you're like, well, I'm doing elementary in Texas, or I'm doing elementary in Praxis, or I'm doing high school math in Florida, or middle school math in Texas. And what's going on here, right? So we're doing these sessions to help you guys out and provide you with different ways to look at problems and to build that confidence. Because here at the Learning Liaisons, one of our major objectives is to clear up the testing confusion, give you the support you deserve in order to nail your exam and be done with it. So our focus is on math. Now, are we going to be just focusing on high school math the whole hour or elementary? No, we've got a mixture here. Now, Amy's going to go through a bunch of problems. You're going to have the opportunity to download those as a PDF. So when Amy starts, just pay attention to the screen. We're going to have a message there for you so you can download the PDF in case we don't get to all the problems or want to practice on your own. She's going to do her best to go across all different grade levels. If you have a question, you feel free to ask Amy your question as well. We're teachers here too, so we can multitask. Our job is to make sure that we give you what you need to be successful. But if you're like, dang it, I didn't have any questions this week, don't worry, we'll be here next Wednesday night as well. So bring those questions with you if you want, and you can ask Amy away. Because here at the Learning Liaisons, we pride ourselves in providing you guys the support you need to pass your exam. So whether you're our Florida teachers here with our FTCE exams, our national exam, Praxis peeps, big shout out to you guys out there too, and especially our newcomers to the Learning Liaisons brand, TExES Prep. So whether you're elementary, middle school, and high school, we've got your back. So sit back, relax, grab your popcorn, get ready to learn some math, and stay tuned for the end because I'm going to jump back on to close this out. And I got a special surprise for you guys who really want to get the real deal prep and get everything you need to be successful and practice, clear up that confusion, and pass your certification exam on the next attempt. So, welcome to the Learning Liaisons community. Always remember, it's when you pass, not if you pass. So without further ado, let's turn it over to the reason why you're here, Amy. You with us, Amy? Let's get going.
Hey everybody, welcome to Wednesday night math night. One of my favorite times of the week just because we get to help you be more confident and competent in your math skills for your upcoming teacher certification test. So it is my pride, it's my joy to be here with you guys and just help out with some math stuff. So that said, I always like to do a get to know you question before we get started as I get ready to share my screen here. So in the comment box, let me know where you're from, what test are you prepping for, and because it's September 11th, let's do you remember where you were on September 11th? I vividly remember where I was September 11th, and I'm sure we all do. And we've definitely spent some time at school today, like moment of silence, remembering those lives that have been lost. So do you remember where you were on September 11th? In fact, my dad, we were super blessed. My dad was supposed to be at the Pentagon that morning, and just a series of events happened and he wasn't there. And so we are super thankful, but also recognize that that was not the case for everybody. And so it's just kind of a heavy day for us. For sure. So do you remember where you were on September 11th? And of course, where are you from and what test are you prepping for? We are going to go over about 8 to 10 problems. We 9 times out of 10 don't get through 10 problems. But we are going to go through 8 to 10 problems. And then, So I am going to connect my screen here, share screen, and then we will get started. All right, let's go ahead and read through the first problem. What is the y coordinate of the point on the line drawn when x equals 42? What is the y coordinate of the point on the line drawn when x equals 42. All right. So this is a problem that everybody needs to be aware of. Everybody needs to understand how to solve this problem because this talks to graphing, linear equations, and then it really stems quite a bit. There's quite a bit of tasks and topics that can stem from this. So what is the y coordinate of the point on the line drawn when x equals 42? So we could sit here and go, okay, 111. So if it's 0, 8, 111, 214, then that means if we have an XY table and we have a 0, 1, 2, and 8, 11, 14, then 3 would be, it looks like we're adding 3 each time. So 3 would be 14, 15, 16, 17. 4, 18, 19, 20. So at least I can get rid of 10. I know it's not 10. 5, and we could do that process all the way to 42. Would it take a while? Yes. Impossible? No. If you have the time, could you do it? Yes. Could you get the right answer? Absolutely. But that said, that process can take quite a bit of time when you don't have that much time. And so the algebraic way to do it would be to create the equation for this line and then plug in x equals 42 to spit out the y. Input, output. If you put something in, you're going to get something out. So is this way a way you can do it all day long? Is this way reliable? I'd say it's almost reliable, because there's a whole lot of computational error that can happen if you're doing that +3 process 42 times. Is it a possibility to get the right answer? Absolutely. So if that's the way that you would choose to do it, go for it. The algebraic way. Y equals mx plus b is the equation of a line. Gotta know that if you're taking any test that's GK or higher, 6th grade through 12th grade, where this is your slope and this is your y-intercept. If you don't know that, you better get studying. Now, I don't have my slope. However, I can find my slope by doing y minus y over x minus x, which is rise over run. So if you can't remember if the y's go on top or the x's go on top, but you can remember rise over run, we rise on a y-axis, we run on an x-axis. So I'm going to rise over run, y's over x's, and I can take these 2 points and solve that equation. It does not matter which y or which x you do first, as long as you do the same thing each time. So if I'm going to do this y first, then I have to do this x first. If I'm going to do this y first, then I would have to do this x first. So I'm going to do 14 minus 11 divided by 2 minus 1. 14 minus 11 is 3 over 1. The slope is 3. So going back to my equation, I just solved for slope. So I'm going to do y equals slope x plus b. What is my y-intercept? Well, they graphed it in such a way that I can figure that out. We can see that this is my y-axis and this is my x-axis because that's where my origin is, and it crosses right here, which is 8. So this right here is the equation of this line in slope-intercept form. So now I can take the value 42, plug 42 in for x, and it's going to spit out a y value to me. So y equals 3 times 42 plus 8. Plug that into my handy dandy calculator. $134. So the y value when x equals 42 is 134, which is E. Questions about that? Questions about that problem? Hi, Valeria. Texas Math 4 through 8. Awesome. And you were extremely little to remember. You were only 3 years old. Yeah. That's like I remember events like people were like, oh my gosh, do you remember where that was? When I was in school, and they were like, I was like, oh, I was too little. So it's crazy to me to think that like people don't remember it because it's such a vivid memory for me. All right, let's move on to problem number 2 and read it together. In the figure below, if the measure of arc ADB is 282, what is the measure of angle ACB? If the measure of the arc is 282, what is the measure of ACB? All right. So this is an interesting one. This is one of those geometry problems where you just have to know the formula. If you don't know the formula, you're really not going to be able to figure this problem out. And it's just that simple. Now, if I look at this angle, could I make an educated guess? I could stick the corner of my paper in here and I could say, oh, this looks like an acute angle. So I'm going to educated guess choose 82. Why 82? Because an acute angle is less than 90 degrees. An obtuse angle is greater than 90 degrees. And a right angle is 90 degrees, which is the corner of your paper, the corner of something. It's the 90-degree angle. However, I've said it once and I'll say it again. Geometry pictures are not always drawn to scale. In fact, you'll often see a little thing under here that says figure not drawn to scale. You'll often see that note, and you can't assume that it is drawn to scale. So by looking at this and saying it looks like an acute angle, that does not mean that it is an acute angle. So how do we figure this problem out? Well, it told us that the measure of ADB is 282. So how do I find the measure of this angle? I take the measure of the arc 1, subtract arc 2, and divide it by 2, and that gives us the angle. The angle formed by two tangent lines that intersect. Tangent meaning that it intersects the circle at one point. So arc 1 is 282 minus something divided by 2 gives me what I want. What is the measure of arc AB? What's the measure of that arc? How would I even figure that out? So elementary people, even though you may not have to know how to solve this problem, knowing how many degrees are in a circle is critical. So if there's 360 degrees in a circle and I subtract 282, then that's going to give me that missing piece. So 360 minus 282 equals 78. So we're going to do 282 minus 78 divided by 2 equals 102. this picture is definitely not drawn to scale. This picture is definitely not drawn to scale based on that information. All right, let's go ahead and move on to problem number 3. Identify the expression equivalent to 4 parentheses 2x plus 1, close parentheses, parentheses x minus 5, close parentheses. So, this is an interesting problem because when you look at the answer choices, which test taking hint, after you read the problem, look at your answer choices because these answer choices are going to kind of guide you in what direction this problem is looking for. The answer choices are going to guide you in the direction of what the problem is looking for because there are lots of expressions equivalent to this. There are a variety of ways that I can take that and create equivalent expressions. So when I look at my answer choices, I need to see what direction are we going. In 3 out of the 4 answer choices, we see that we have 2 sets of parentheses without a coefficient in the front. Coefficient being this guy right here. We have 2 sets of parentheses without the coefficient in the front. So that tells me that they took that coefficient and multiplied it into the problem. Or they multiplied this thing all the way across to get no parentheses. However, I can very quickly cross D off. Why? Because with this kind of expression, if I multiply that all the way through, I'm going to end up with some sort of x squared. It doesn't matter what kind of x squared I land with. This expression does not have an x squared. And you say, Amy, how do you know that there's an x squared? Because I know that when I distribute this all the way through, when I distribute this guy all the way through and it ends up multiplying times that x times x equals x squared. Now, we know that that's 2x times x. Semantics, 2x times x is still going to give me a 2x squared. And this expression does not have any x squareds. So I know that D is out already. That said, now I can look through these answer choices and decide, okay, what did they do? Did they A, multiply the 4 into the 2x plus 1. B, multiply the 4 into the x minus 5. So they did something like this. Or did they do something completely different? So let's multiply this 4 into this expression. Let's distribute the 4. 4 times 2x is 8x. 4 times 1 is 4 times x minus 5. Now, here's a tricky part. The 4 does not multiply all the way through. Now, if it was something like this, then the 4 would go all the way through. However, the fact that the parentheses close right here means that I'm not going to multiply that all the way through. I'm going to multiply it into all of the 2x parentheses, but by multiplying the 4 also into the x minus 5 would be very similar to doing this. Instead of doing 4 times 3 is 12 and then 12 times 3 is 36, this multiplication all the way through would be like doing 4 times 3 times 3 and then doing 4 times 3 is 12 and then 4 times this 3 is 12 and then that equals 144. And you and I both know that's not accurate, and that would be very similar to what's being done over here. And so we're not going to do that. So is this an answer? 8x plus 4. Well, the only one with an 8x plus 4 is this one. And did they leave it as an x minus 5? No. They multiplied that 4 into the x minus 5, and that is not accurate, so it's not B. So now let's try multiplying the 4 into the x minus 5. So we have 2x plus 1 times 4 times x is 4x. 4 times negative 5 is negative 20. Do we see that anywhere? We do, but it's in a different order. I see it right here. So what is that? The same thing. That's our answer. Because multiplication is commutative. Commutative property says that I can do A times B, and that's going to equal B times A. So if this whole thing is A and this whole thing is B, it doesn't matter if I switch the order. They are the same thing. Questions about that? Now, let's do a little game. Let's do this. Let's do a little error analysis, because you and I both know that these test companies love to give error analysis problems. So let's pretend this problem said, what error did the student make when trying to find an equivalent expression for this expression? What error did the student make when trying to find an equivalent expression for that expression? I want you to think about that for a minute. What error did that student make? That student only multiplied the 4x, or the 4, not the 4x, to the 2x, and they got 8x. But then they were supposed to multiply the 4 times the 1 to get a 4, and they only got a 1. And the student multiplied the 4 into this x too, but didn't multiply it into this one. So they over-distributed in some areas, but under-distributed in others. Interesting. Let's go ahead and look at letter B. What error did the student make when doing this one? They absolutely over-distributed. They distributed that 4 all the way through, which I guess is good, because you're supposed to distribute all the way through, but not when you have multiplication. You want to distribute all the way through that first set of parentheses and then stop. And then we know that this is the correct answer. Excellent job. Excellent job. All right, let's go ahead and look at the next problem. A water balloon's height, h, in meters, dropped from a 3rd-story window, can be described by h equals negative 16x squared, or t squared, plus 30, where t is measured in seconds. Determine how long it will take for the balloon to strike the ground to the nearest 10th of a second. Now, y'all, please do not let a problem like this scare you. Oh, by the way, this problem right here and the next problem, so this one and this one, and actually this one too, were specific requests by one of our amazing Learning Liaisons clients. So if you have a request for a problem to be solved, please tag me on social media. Please send it to me. Please let me know in the comment box, because I always like to have a next week section. I knew I was forgetting something in like my introduction. I was like, man, I finished my introduction so quick this time. That's why in the comment box, let me know what you want to see from me in the upcoming weeks. I love tailoring these sessions for you. Not only does it help me know what you're struggling with, but it helps you get problems solved that you need help solving. And so I love taking your feedback and adding problems in that you are struggling with. So like I said, this problem, and the next other two problems are specific requests from a Learning Liaisons client, individual on our Facebook page, so you do not have to have like one of our products to be able to request a problem on our Wednesday night free sessions. So let me know in the comment box or on social media, what would you like to see me go over in the upcoming weeks? And I will be happy to add that into the upcoming sessions. All right. So side note, done. Please do not let a problem like this scare you. When I explain it, it's going to make total sense, but the amount of words can sometimes intimidate people. So the height equation, when something is thrown off of a building or something like that, always starts with this negative 16t squared. However, do you need to memorize that? You don't, because 99.9% of the time in a height equation, they are going to give you the equation. So they gave us the equation. So really what this says is blah, 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 blah. Hey, here's a really important equation where t is seconds. So t equals time. How long? There's the question. How long will it take to strike the ground? Now, is the blue part important? Yes, it's important because it provides context for what we're doing. But if all of those words confuse you, look at the equation, look at what it's asking, and then go back to the story. So the story is telling us that a water balloon is dropped from a third-story building. So here, I drew that too big. Here's my building. And here's my water balloon. And it's dropped. Right? And if I created this into an XY coordinate plane, where is it hitting the ground? In my graph, where is it hitting the ground? What part of my graph? What could I label that as? My x-intercept. Because the height is how tall the water balloon is in that moment. And then the time is how long it takes. So this is how tall my balloon is. This is how long it takes for it to get to that spot. So I'm looking for how long does it take for the height to be 0, for the balloon to hit the ground. Well, if the height is 0, if I'm looking for where the water balloon hits the ground, then my height is 0. And I can solve for t, which is time, which is what I'm trying to find, because it says how long. If it's asking how long, I'm looking for t. So how do I solve this? Well, those of you who are very familiar with parabolas and quadratics, we immediately go to, I got to factor it. I got to use the quadratic formula, stuff like that. However, there's no third piece to this problem. There's no third term. So I can just subtract 30 to the other side. I don't have to factor this. All I'm trying to do is get 0 or to get t by itself. So whatever I do to one side, I have to do to another. Get t by itself, divide both sides by -16. T squared equals -30 divided by -16. Which is 1.875. And then I can just square root that, which gives me t equals 1.369. And it says round to the nearest tenth. So if I have 1.369 and I'm rounding here, which way is that going to round? Up. So that becomes 1.4. I'm so glad that you were able to figure out where you went wrong here. Yes, the next step completely gets overthought. Now, here's another way you can do it if you were so lost. Let's do it again. Let me show you how to quickly do this again a different way using our answer choices. In fact, my nephew just took the SAT, and this wasn't an SAT problem, but this is actually how I coached him on how to take the SAT, because there was plenty of problems he didn't know how to do algebraically, but he could use his answer choices to figure it out. So if they gave me the equation, and I know that it's 0 equals -16t squared plus 30, then couldn't I take each answer choice and plug it in for t and see which one gets closest to 0? So let's try that. I'm going to do each one in a different color. Now, if you've done math nights with me before, or you've done boot camps with me before, I never, ever, ever start with A. Why? Because if I start with A and it's not A, and then B and it's not B, and then C and it's not C, and then D and it's D, then I have to do it 4 times. But if I start with B or C, then I can get a gauge of whether I need to go up or down. And it could cut my time in half, but at least by a 4th. So I'm going to start with letter B. So zero equals -16 times 2.8 squared plus 30. 2.8 times 2.8. 7.84 times -16 is -125.44 plus 30. Is that even close to 0? No. So I know it's not 2.8, which tells me it's 99% sure not going to be 2.7. See how I just eliminated 2 answer choices? Now I'm going to try 1.3. 0 equals -16 times 1.3 squared plus 30. 1.3 times 1.3, 1.69 times 16, -27.04 plus 30. We are getting closer. So this equals 2.96. But I'm going to do the next one just to see, because remember, it said round to the nearest tenth. And so I want to make sure I'm not too far off. So 0 equals -16 times 1.4 squared plus 30. 1.4 times 1.4, 1.96 times 16. negative 31.36 plus 30, negative 1.36. So even though none of these equals 0, that's because our answer was actually an irrational number. And so we just have to choose which one is closer to 0, which would be that 1.4. But if you didn't know how to do it this way, that's one way that you could do it without feeling defeated, right? All right, let's move on to the next problem. Which of the following triangle congruence theorems is most appropriate to justify triangle ABC is congruent to triangle DEF? Triangle ABC is congruent to triangle DEF. So congruency and similarity are two different things. Congruency means the triangles are exactly the same. Whereas similarity means the triangles are proportionate. So what does that all mean? That means that we are looking for congruency. We're looking for these triangles to be exactly the same, angles and sides. Whereas in similarity, the angles could be the same, but the sides could be drastically different. They are just proportional to one another. So if you ever see an angle theorem, you can automatically write that off. If you see an angle theorem, you can automatically write that off for congruency, because that is not something that can prove congruency. You have to have something else there. Now, when we're looking at these, side absolutely proves congruency. However, we do not have three sides here that are showing congruent. I don't have this side, and this side, and this side, and this side, and this side. In fact, I have no idea what this side is. So I can't use side. They haven't told me that side even, or that all my sides are equal. Side, angle, side. Hypotenuse leg can also be completely thrown out before we even get started, because hypotenuse leg is for a right triangle only. Because in a right triangle, your hypotenuse is going to be across from your 90-degree angle. So this is my hypotenuse. Your hypotenuse is across from that 90-degree angle, and it can be used with a leg to prove congruency. But neither of these have a right angle, so they are not going to have hypotenuse leg as an option. So I'm down to side, angle, side, or angle, side. Is it going to be side, angle, side, or is it going to be angle, side? So we have an angle here, an angle here, and a side here. And over here we have an angle here and two sides. So what does that tell me? Well, what we do know is that if this angle, let me go back. If these two angles are the same, then I can assume that these two sides are the same. And so if these two sides are the same, then I can assume that these two angles are the same as well. And if both angles are the same in both triangles, then I can rightfully assume that these angles are congruent as well, because all triangles have 360 degrees. All all triangles equal 180 degrees. And if the two angles in both triangles are the same, then our third angle is going to be the same as well. And what I just did is verbalize a proof. So if you're knee deep in geometry, what I just did was if this, then this, if this, then this, if this, then this, and I just did a proof. So let's go back. Is it side, angle, side, or is it angle, angle, side? So what we were officially given were these three things, the three things circled in pink, and these three things. So I have angle, angle, side, and I have angle, angle, side. Could it be side, angle, side? It could, but I don't have this side right here or this side right here. So they really didn't give me two sides. And when you do side, angle, side, it has to be sandwiched. It has to be like side, angle, side. And they didn't sandwich that for us. So it is going to be angle, angle, side. Questions? All right, let's go on to our next problem. This problem was also requested specifically. So again, you're noticing that if you request a problem, it's probably going to land in our Wednesday night math night. And in fact, the next problem that we go over was also requested. So let's go ahead and do this problem right here. Which of the following correctly describes the changes seen on the coordinate plane when f of x equals x squared is modified to g of x equals 3 parentheses x minus 2 squared plus 7? Vertical stretch of 7, horizontal translation 2 units right, vertical translation 3 units up. Vertical stretch of 3, horizontal translation 2 units left, vertical translation 7 units up. Vertical stretch 3, horizontal 2 right, vertical 7 up. Vertical stretch 2, horizontal translation 7 right, vertical translation 3 up. All right, when I'm solving a problem like this, I'm going immediately to those answer choices and I'm looking for what's different, okay? So I see that each of these answer choices is structured the same. Vertical stretch, vertical stretch, vertical stretch, vertical stretch. Horizontal, 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 horizontal. Vertical translation, vertical translation, vertical translation, vertical translation. So now I just need to be able to know which pieces of this translation match which pieces. Anytime you have a translation of a graph, regardless of whether it's absolute value or a cubic function or anything like that, regardless of what it is, an external translation, so this guy right here, is going to be a vertical shift or translation. Anything on the inside is going to be horizontal. And anything being multiplied is going to be a stretch or a shrink. That applies for linear equations. That applies for cubic equations. That applies for absolute value equations. It doesn't matter what kind of equation you're dealing with when you're dealing with translations. That's the format. If it's outside, it's vertical. If it's inside with the x, it's going to be horizontal. And if it's on the outside being multiplied, it's going to be a stretch or a shrink. So inside or outside follows the signs. Inside is opposite. So with that said, outside follows the signs. So this is going to be 7 up. Inside is opposite. So we would typically think of -2 as a left translation, but it's going to be a right translation. So this is going to be right 2. when I look at my answer choices, the only two answer choices that have a vertical translation of 7 up are B and C. So I can cross off A and D. And then is it 2 units left or is it 2 units right? It is 2 units right, which is C. Alrighty, let's go ahead and go to our next problem, which was also requested by somebody. An 8th grade classroom consists of 14 girls and 16 boys. If 10 of the students are to be selected at random to help a 5th grade math class, determine the probability that all boys will be selected. Determine the probability that all boys will be selected. All right. So this kind of probability, I wouldn't worry about a ton. But let's go over it. This notation right here is combination notation. So all they're saying is use the combination formula to solve for the top, use the combination formula to solve for the bottom, for the denominator. So when we're calculating probability using combination notation, that was a lot of syllables in one sentence. In fact, when we're calculating probability in general, let's just start there. The top is always our desire, and the bottom is always our total possible. No matter what type of probability you're doing, the top is always your desire, the bottom is always your total possible. So my desire is that all boys will be selected, right? So if I'm using combination notation, which is just a big C in the middle, the numerator represents the number of desired outcomes, which is boys, using the combination formula, and the denominator represents the total possible, using the combination formula. And so if we're looking at the combination formula says this, where N is the total number of items and R is the number of items chosen. So if the top is my desire is boys, my desire is 10 students, and how many boys do we have? 16. So my top is going to be C. My total possible is 16 boys, but my desire, the number of items I'm choosing, is 10 over my combination. My total possible is 30 kids in all. 14 plus 16 equals 30, with 16 boys total. This one. But like I said, that is not a common way for the probability to be asked. So I wouldn't stress about that. I would stress about understanding probability as a whole. Hey, Leah, my friend, it is good to see you. Hey, Tanya, it's good to see you too. Happy Math Wednesday, my friends. Happy Math Wednesday. I love Wednesdays. All right, we have time for one more problem and then we will close it out. A linear equation, y equals mx plus b, describes the relationship between y and x. If the line intersects the y-axis at 0, 5 and has a slope m equals 3, which of the following equations represents this line? Which of the following equations represents this line? y'all, this is slope-intercept form, and we talked about this earlier today. And these are my favorite kinds of problems because they literally give you the template. So all you have to know is that your M is your slope and the B is the y-intercept. And so I'm just going to plug my slope in, which eliminates B and D because my slope is not negative. And I'm going to plug my y-intercept in, which is a positive 5, which means my answer is A. That's it. All right, let's go ahead and chat about next week. What do you guys want from me next week? What would you like to see from me next week? I am going to hang around for 1 or 2 minutes. I'm going to turn it over to Dr. A, but I'm going to hang around for 1 or 2 minutes and see what you want to see from me. Excuse me. And then we will go from there. So next Wednesday, I will see you all right here, same place, same time. But let me know in the comment box what you want to see from me next week, or find me on Facebook and tag me, and I will see you guys next week. Have a great night.
All right, so wasn't that an amazing session? Now, I know, depending on what exam you have to take, you're like, man, that was great, but she didn't address everything I needed. She focused on all different questions, and I just need elementary, or I just need middle school, I just need high school. Don't worry. Since you're still with us, I've got a special surprise for you. If you the coupon code, all capital letters, SINK35, that's SINK 35. That will take off 35% off any of our prep courses on our website at the Learning Liaisons. Doesn't have to just be math. It could be anything that you need that we offer. And this is going to be an ongoing deal for you guys who attend these live sessions, because these are great. I'm sure Amy opened your eyes to some new concepts, some new ways to tackle problems, building that confidence. But this is just a smidget of your exam, the concepts on your test. So if you want the comprehensive view with the practice with Amy, with the practice test, with the lessons and the content review, we've got your back on our video boot camps, which all of them feature Amy Sink, your math specialist. So if you want to take advantage of that, the code is SINK35. You can use that at checkout on the learningliaisons.com website. And all that information is on our website as well, and on the bottom of the screen in this video. So we are here to help you. Once again, always remember, it's when you pass, not if you pass. Thank you for joining us again today, and hopefully we'll see you next week too. Talk to you soon.